Okay, so. Right? Now, squaring function. And I asked for the outputs, right? I didn't get many answers. Then I asked specifically, well, if the input is -4, what's the output? And everybody told me, well, 4, right? So you know how to calculate the outputs, you're just afraid to say because you're not sure about inputs and outputs, okay? But you know. So what are the other outputs?
1, 4, 0.
Oh, you already said 4,
A 4.
okay? Now 4, 1, 1/4, 0. Any others? Is that all the outputs you've got? Well, what do you have more of, inputs or outputs?
Inputs.
What's that tell you about whether this is 1-to-1? What's 1-to-1 mean? For every output, there's exactly one input, right? Now, for every output, there was exactly one input, and there are 4 outputs, then how many inputs would there have to be?
Same amount.
Sorry?
Have to be the same amount.
Yeah, it has to be 4, right? And there's more than 4, so you know that some of these inputs have more than one output. Gotta be careful. Get sharp things away from me at least. Okay, right? And it's clear from looking at this, you know, that, well, can you give me an output that has more than one input? Anybody able to choose one of these outputs that has more than one input? Four? Okay, what are the inputs that give you 4?
-2 and 2.
Okay. What about 0? How many inputs give you 0?
1.
Yeah, 1, 0, and 0. No, just 0. Okay? Right? But these other 3 all have 2 inputs that give you the output, right? So, output 4 has 2 inputs, -2 and 2. Okay? So right away the function is not 1-to-1. It's seen to not be 1-to-1. Because in order to be 1-to-1, every output has to have exactly one input, and we just found an output that has 2. And of course we can say, well, 1, -1 and 1, 1/4, -1/2 and 1/2, okay? So, outputs 1 and 1/4 each also have 2 inputs, and I know you can tell me what they are. Okay? looks like only 0. Has exactly one input. Does that make sense? Okay. Now, that's easy enough to understand probably. We could look at the table. There's the table, right? Okay. And we see that 4 appears for 2 different inputs. And we could say the same thing for outputs 1 and 1/4. And it's clear from the nature of the function that there, for any number except 0, there are two numbers that you could square to get that number, right? Now, do you remember how we construct the graph of the square root function?
You flip the inverse.
Yeah. You flip these columns. Now your x's are the y's and your y's are the x's, right? Okay? And if you graph that, what's your graph going to look like? Yeah, it's going to be like this, right? And everybody's graphed it, I hope, a number of times. Okay? So everybody understands this, I hope. Is that a function? What's the definition of a function?
One input for one output.
Exactly. Function. Okay? Now the square root function.
Excuse me.
Well, if we reverse the columns of the squaring function, I don't have room to write them all, so I kind of omit 1/2, but we understand it should be there. Still, we can make the point. We get 4, 1, 0, 1, 4. We get 2, -2, -1, 0, 1, 2. Right? So this is not a table of a function. Here we have input 4 has 2 outputs, so we can't answer the question, what does this function give us if x equals 4, right? Could be 4, could be -4. So this is not a function. Now the square root is a function, and you can verify that the square root of 4 is 2, and the square root of 1 is 1, and the square root of 0 is 0, right? But the square root of 1 is not -1, and the square root of 4 is not -2. Square root of 4 is 2, not -2. So what do we have to do? We restrict the domain as I've seen many of you do in your homework correctly, okay? So you know about restricting the domain. And we get a function. So we restrict the domain to this. Now we got the square root function with its half of a parabola on its side shape, right? So we need to understand this. Now this is something that's covered very early in the course that nobody understands because they don't have a context for it. So we talked about it some time ago. Well, that kind of loosens up the old mental soil so something can grow in it, and that's time for it to grow now, okay? So we want to put these ideas together, and you should have a good foundation for it because you understand the graphing, you understand these functions pretty well, okay? Fair enough? Now, there's another aspect of one-to-one we'll look at.